Hello, I've got a interesting looking Sudoku here with a unique rule that I'm going to try. I found this one on Logic Masters Germany, as I often do. This one, let's see, we've got it in F puzzles today. But with the F puzzles link, the check for highlight conflicts is going to be turned off because it doesn't quite understand the rule, and when you finish, it's not going to stop the timer. Because there's a different rule with the palindrome. So we'll get to that in just a second. But this is by Big Tiger, and it had a 98% rating on Logic Masters Germany with the 3 stars for difficulty. So just the perfect kind of puzzle that I like to do. I'm going to leave a link in the description where you can try this puzzle, and I'm going to try it now. So the rules. The white circles are normal difference rules. Now, this is called Absolute Valudrome, and the rules on Logic Masters Germany actually talk about absolute values between cells, but I'm just going to think of those as differences. I read through the rules, and it's differences is what it is. He's calling it absolute values because um, it could be, either one could be the big one, but just the difference between the two. So the white ones are normal difference circles. The outside digits are little killers that give you the sum of the digits along the diagonal, like the 17 here. Those three sum to 17. The palindrome is the interesting part. So normally with the palindrome, the digits read the same forward and backward, but that's not the case with these. What this is saying is the the difference between each set of two along the line is a palindrome. So essentially, the difference between these first two is the same as the difference between these two. Then the difference between the second and third digit is the same as the difference between the second and third digit the other way, all the way around the line. So that sounds pretty interesting. I thought it sounded like it would be fun, so I'm gonna give it a shot. And you try it yourself. Let me know how it goes in the comments below, and we'll see how I do with it. So, I mean, the first thing I immediately see this 8, which has to be 1 and 9, right? Because a difference of 8, the only way to get a difference of 8 is with 1 and 9. So this is going to be 3 or 7 then. It's either going to be 1 with 3 or 9 with 7. This one's going to be 5 either way, whether it's 1 or 9. A difference of 4 has to have 5. And then, right, and then the difference of 2 would be 3 or 7. Okay. So this 1 and 9 are going to limit us some up here. Ah, and that's interesting too. So when you have two, so just like with normal crop key stuff, these chains of dots I think are really useful usually. Yeah, we've got the same thing down here. So the 2 4s here. So and the 2 3s, because there's 2 of them in a row, you couldn't say 9 6 9. It's not going to be able to jump down and then back up again. Like with the 3 and the 1, we can go 9 6, and then we could either go 5 or 7. It can go down again, or it can jump back up. But when it's two digits that are the two differences that are the same, it can't jump back up again, or alternately, it can't go up and then back down again because it's these two are going to be the same digit then. So it's going to have to be a chain. So it's going to have to be like 1 4 7 or something. It's going to have to continue in a chain like that. Which then means, so these two are 6 apart. Which then means that the 5, the difference of 5, so even if this is as small as possible, 1, you get to 6, you can't go back, or 1 to 7, sorry, because it's a difference of 6. 1 to 7, you're not going to be able to keep going up, because you've got 6 here plus 5 is 11, and you can't have a difference of 11. So this is going to have to either go up and then jump back down, or go down and then jump back up. So, and this can't be 1 or 9. So we could do 2, 5, 8. We could do 3, 4, 7. We could do, or the other way around. This could be 7, 8, and this could be 2 or 3. I think that's the only options there. Because this can't be. Can this be 6? Wait a minute. Wait a minute. What did I do? Hold on. 2. I'm losing my mind. I don't know how to do math. Okay, let's try again. 2, 5, 8. I think I typed a 4 on accident, and that messed up the rest of it. 3. It can't be. Yeah, it could be 3, 6, 9. Yeah. Wow. Okay. Uh, but it can't be 4, 7, and then it'd have to be 10. And we can't start with 1. And this can be 8, but it can't be 9. So this can be 8, 5, 2, but it can't be 3 down here. That's what they are. Okay. So then this would be 7, 3, or 4 to fit with the 2, 8, or 9 there. Okay. I'm going to look at the 4s down here. I think they're even more restricted. So, although we don't have the 1 and the 9 to help with that. But, so this could be 1, 5, 9. Yeah. Oh, right, right. Because essentially what we're saying is these two are a difference of 8. So this is a 5 no matter what. Yep. And these are 1, 9 pair, which means this is 4 or 6. Okay, so that 5, nope, doesn't help us up here with eliminating anything. Okay, so we also have this 18 little killer up here. We've already got 5, so we need 13 more, and it can't be 9 and 4. Can't be 8 and 5, so it's got to be 6 and 7. Because we already have the 9 there, and we've already got the 5 here. 6 and 7, so that makes this a 3 and a 1 and a 9. And these are 2, 4, and 8. Okay, so this difference of 4, 3. Now, these two could be as little as 1 difference, because you could go, like 1, 4, 2. So it can go up and back down. Okay, so that's less helpful. These, we can get rid of our 3 here. It's something. Which means this can't be an 8 anymore. Right? Yeah. So this can't be an 8. Which means that can't be a 2. Because for this to be a 2, it has to be 2, 5, 8. We've got this down to 2 options here. So that's good. We're getting there. I'm gonna color a few cells along this palindrome just to help. Because I was just thinking these two are 3 apart. I wonder where its corresponding difference is gonna be along here. So I'm just gonna go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm just gonna, and I clicked off of it. I'm just gonna highlight some of these with colors so we can kind of keep track of where we are. 5, 1, 2, 3, 4, 5. So those 2. So the ones that are colored are the same spot along the palindrome. 5, 1, 2, 3, 4, 5. Okay, so those are red. So we know that these two then down here have to have a difference of 3 because those two have a difference of 3. That's what that's telling us. And like this one right here, which is the 2 after the yellow, are either a difference of 1 or 2. All right, we got to use our little killer again. So the 9 little killer, if this is a 6, we would have to put 1 and 2 in these other 2 cells, but we've already used 1, so this actually has to be a 4, which is going to give us 9 and 1 right there. And now we have 4, so these have to be 2 and 3 because they have to equal 5 and they can't be 1 and 4. So coming into the blue, we're either a difference of 1 or 2. So these are a difference of 1 or 2, but we don't know any of those yet. So let's see what's left in this box. 6, 7, and 8. All right, and coming, that's going over to here, isn't it? We don't know about this one, what the difference is. That's going to be the same as the difference here. These 2 coming into the blue. So the difference there would be 2, 3, or 4. Yeah. It's not going to be very helpful. Okay. 1s. 5s. Okay, I'm gonna look at. Let's look at the 4. So this can't be 1. It could be 2 and 6. That would work. Can't be 3. Could it be 4 and 8? I think so. 5 and it can't be 9, but it could be 5 and 1. 6 and 2, 7 and 3. Yeah, there's a lot of options, isn't there? 8 and 4. Too many options. Okay. That's not going to be helpful. I don't want to do that. Okay. Let's see. Up here, we've got 8, 5, 2, 7 as an option, right? 5, 2, 7. 8, 5, 2, 7, or 3, 6, 9, 4. I think those are the options. Yep, and those both seem to work. These two are going to be the same as that, so it's either a difference of 1 or 2. Okay, it's got to be something with these 4 down here. Let's look at these again. So oh, right. Okay, so what I was thinking is this can go up and back down or up, but we have to remember that these have to be a difference of 1. So let's just assume this is a high number, first of all. We're going to go down 4. If we go down 2, that's 6. And then we come up 3, that's going to be a difference of 3 here. So actually, it needs to be, right, so the 2 and the 3 need to be the same direction, because then we'll have 5. So we'll go either down 4 and up 5, which would have a difference of 1, or we'll go, if we start low, we'll go up 4 and down 5. But either way, this one, right, so these two have to be the same. So essentially, these two have to be 5 apart, is what that's telling us. Okay, so this could be 2 and 7. This would have to be 4. Can't be 3. If this is 4, can't be 4, because we got a 4 over here. Can be 5. But if it's 5, you can't do a difference of 5. So that can't work. So this can be 6. This would have to be 4 again. And this would be 1, but it can't be 1 because of the 1 over here. So that can't be 6. This could be 7. This would have to be 5 and 2, but we've already got a 5 over here, so this can't be 7. 8, this would be 6 and 3. That, I think that works. 8, 6, 3, this would be, oh, but this would have to be 4, and this can't be 4 because of the 4 there. So it can't be 8, and this can't be 9. So there we go. So that's 2, 4, 7, 6. Okay. There we go. That's going to help. So this can't be 6. 6, 7, 2. Okay, now we know this is a difference of 5, so these two have to be a difference of 5, which makes that one a 1. So what else do we have here? 3, 5, 8, and 9, I think. This one can't be 5, 9. This one can't be 3. All right, and so right here, this difference is, well, and let's look at our little killer, because we've got a 6, so these two need to equal 11, which is going to have to be 8 and 3, which makes that a 5 and a 9. There we go. We got a whole box done. How about that? 3, 5, 9, 6, yeah, no, we can't use those to get these yet, but there's no 8 there, so that puts the 8 right there. And the 3 gives us the order of the 2 and the 3. And that 3 is going to give us this up here. 2, 7. Awesome. Okay, so this can't be 2 anymore. All right, so, and we've got some differences here. So we've got 5. The next one has to be a difference of 4, which is going to be right there. So that makes this a 5. These two. So what do we've got along here? 1, 2, 3, 4, 5, 6, 8, and 9. So the two after the yellow, these two. Oh, no, no, that's going up here. That's along the line up here. Okay. 1, 3, and 7 across there. So these two have to have the same difference as the 5 with the 6 or the 7. So it's either 1 or 2 difference. So we can't have a 1 or a 3 here because they'd have to have a difference of 1 or 2 with those down there. So this is a 7, which means that is either, yeah, 6, 8, or 9. Those are all possible then. Oh, well, the 3, you can't have a difference of 0 here because it has to be the same as the difference there. So that's going to have to be 1 and 3, which makes a difference of 2. This is going to be 3 or 7, but there's already a 7 down there. So it has to be 3. And now we're looking at 5, 7, or 8 for our difference right here, which has to be 5 because you can't have a difference of 7 or 8 with a 3. So that makes that a 6. And we have 1 or 2 there, which we have here. Okay, and then it's also 1 or 2 coming from the 8. So, right, so this has to be an 8, because if it was 9, it would be a difference of 3, and we can't do a difference of 3 up here. So it's a difference of 2, which makes that a 6. That's a 1. This is 1. Yep, works out perfect. Okay, this can't be an 8, so it's a 2 or a 4. That's a 2 or a 4. Now let's look at this one. So we're second and third past the yellow. So that's these two. It's a difference of 1. So that's going to be a 4 and a 2 and a 4. Gives us an 8 there. Oh, we got the 7. Should already had that from the 6. And now we are really moving. Okay. This is 7 or 9. These are 1, 2, 6. 5 and 4 goes with 7 and 8. Then it goes a difference of 4. So this is going to have to be an 8 to have a difference of 4. And then a difference of 1 coming into the blue. So that's 7 or 9. And then coming into the red here, it's a difference of 1. Whether this is 6, 7 or 7, 6, it's still a difference of 1. So this one has to be 4 or 6. To be a difference of 1 with the 5. And then this one is a difference of 3. So that's going to be, well, the 6 would have to have a 3 or a 9. We already have a 3 or a 9. So that's going to have to be 7 and 6. And so then a difference of 3 makes that a 4. 2 and 5 in there. So 4 to 3, that's a difference of 1. The 2 cells after the red. So these two. So this has to be 3 or 4. But we have a 4 there. So it's got to be a 3. That leaves us with 7, 8, and 9 there. That one can't be 8. Now, the next one is a difference of 1 or 2. So this is a difference of 1 or 2. It could be 4, or it could be 1 or 5, actually. There's a lot of options there. Okay. Let's see, what do we need up here? We need 1, 4, 6, 9. This one can't be 9. Or 4, or 6, actually. So that's a 1. This can't be 1 or 6. That's a 9. It's 4. We got a 4, 6 pair there. Which means this is not a 4. It's the 4, 6 pair. This is 1, 5, and 3. This is the 3, because we have a 1, 5 pair there. So, so this one was a difference of 1 or 2, but we got rid of the 1 option, because it couldn't be a 4. So this is a difference of 2, which is right here. So this has to be 5, 2. And now the next one is either going to be 8 or 4, going from the 1 to the 9 or the 5 to the 9. 8 or 4, and the only way to do 8 is 1 and 9, and so we obviously can't do 8 with a 5, so it's got to be a difference of 4. So that's going to give us those. This is a difference of 4, so that's a 1. Now the 9 to something and the 1 to something, so these have to be the same distance from, so essentially they're kind of going to be on opposite sides of the 5, so it could be like 2 and 8, 3 and 7, 4 and 6. They obviously can't be 5 and 5, because But it could also be the other way around. I mean, it could be like 8 and 2, where it's a long ways from the 9. But let's just see. Can we do 2 and 8? Yes. No, we can't. There's an 8 up here. Okay, how about 3 and 7? Note the 3. 4, no. 5, 6. Oh, actually. Okay, so this can't be 1, 3, 4, 5, 6, or 8. It could be 2, but you'd have to have an 8 up here, which you can't do. It could be 7 with a 3 up here. That would work. Or it could be 9 with a 1 up here, actually. That would be a difference of 8. Okay, so there's 2 options there. Could be 7 and 3 or 9 and 1. Ah, but we have a 7-9 pair right here. Oh, but that was, yeah, the 7-9 is down here. Never mind. But we do have a 7-9 pair. That's interesting. There. Okay, what's left over here? 2, 4, and 6. This one can't be 4. So from the blue, coming out of the blue cell there, is a difference of 1 or 3. So going this way is a difference of 1 or 3. So if it was 1, it would have to be 6. It couldn't be 8. 3 would be 4 or 6. So it's a 4 or a 6 there. And now we have a 4-6 pair in the row there. So this is 1 and 9. And the one down here will give us the order of those. This is... Oh, wait, we have a 9. So this has to be 7. So then... Hold on. Okay, I'm back. So... Let's see. After the blue, it's either 1 or 3. Yep, 1 or 3. And then the next one is either 3 or 5. So it could be 6, 9, or 2, 7. But this can't be 8. So now we have a 7, 9 pair, which gives us the 8 right there. So now these two before the red, that's these two, are a difference of 2. So 2, and it can't be like 4 with 6 or 6 with 4, because whichever one is here, the other one's going to be right there. So for a difference of 2, it's going to have to either be 4 with 2 or 6 with 8, but it can't be 8, so it's going to have to be 4 with 2. 6. That gives us 3 and 4 right there. Oh, that's a 6 anyways because of this 4. This is a 5. Okay, so 1, 5, 1. So this is 1, and then 5, and then 1. That works. Do we have... the 1 here gives us the 3, which means that's a 7, because it needs to be a difference of 6. And now these two, again, are going to have to kind of be... So it doesn't quite work the same way, because with the 1 and the 9, since they're the extreme edges, you're moving in no matter what. But with these two, like for example, if this was 7, 8, this wouldn't have to be 3, 2. It could be 3, 4. So, but we've got 6 and 9 there, and that 6 is going to give us the order. So it's 2 and then 3. Okay, so there's a difference of 2 and a difference of 3. So this could be 1 or 5, but it can't be 5, so it has to be 1. The next one's a difference of 3, makes that a 4. And now what's left in the middle here? 2, 5, and 8. So these have to be the same. So it could be 2 and 8. Yeah, it's going to have to be 2 and 8. Oh, but it could be the other way around, though, couldn't it? But it can't be... The 5 has to be in the middle. But I think actually these could go either way, because 6 to 2 is going to be 4. 4 to 8 is going to be 4, or 6 to 8, 4 to 2, yeah. But the 2-8 pair gives us 6, 2, that 7 over here has probably been sitting there for a long time, 7 and 9 and 9. And this is 6 and 4. And the 3 down here gives us the 4 and the 3. and the 8 makes that 2 and 8. And so I think that is the solution. All right, so that was Absolute Valudrome by Big Tiger. Kind of a cool idea with using the differences on a palindrome instead of the actual digits as a palindrome. And I guess, you know, you could take a normal palindrome where the numbers are the same order would have this same property where the differences would be the same. But it's kind of interesting to take a palindrome that's not a normal palindrome and still have all the differences be the same. I'd be interested to know how long it took to come up with a solvable puzzle that actually had a palindrome with that property. But pretty cool. All right, hope you guys enjoyed that. If you tried it, let me know what you thought, and I'll see you again soon. Thanks.